In the realm of data management, both traditional databases and blockchain play vital roles, but they operate on vastly different principles. Today, we're going to dive into these differences to give you a clear understanding of these two distinct yet interconnected concepts. We'll start with a brief introduction of what they are, setting the stage for the more in-depth discussion to come. Traditional databases like SQL or NoSQL are centralized repositories where data is neatly organized in tables or collections. On the flip side, we have blockchain, a decentralized distributed ledger system where data is stored across a network of computers. These two systems, while both pivotal in data management, have vastly different structures, principles, and use cases. So, if you're eager to understand these differences, how they work, and why they matter, you're in the right place. Whether you're a student diving into the world of databases or a professional seeking to understand the unique features of blockchain, this video is for you. First, we delve into traditional databases. These databases, such as SQL or NoSQL databases, are centralized repositories where data is stored in tables or collections. Imagine a vast library of information, organized into neat rows and columns, or in some cases, flexible collections. This is the essence of traditional databases. But what gives these databases structure and order? The answer is a central authority. This authority can be a company, a government organization, or any entity that maintains and controls access to the database. They keep the data secure, ensure it's up to date, and manage who gets access to what information. These databases operate under a centralized structure. It means that all the data is stored in one place, managed by one entity. This centralization offers a clear hierarchy and control over the database, making it easier to manage and maintain. Controlled by a central authority, typically a company or organization, traditional databases offer a centralized structure for data storage and management. On the flip side, blockchain is a decentralized, distributed ledger system. Instead of a single central authority, data is stored across a network of computers or nodes connected by peer-to-peer communication. Imagine a giant, transparent, and incorruptible digital ledger where every transaction or data point is recorded and visible to everyone on the network. That's what blockchain is. This network of computers or nodes each hold a copy of the entire blockchain. When a new transaction happens, it's broadcasted to all the nodes. They work together to validate it using complex mathematical problems, a process known as mining. Now let's think about the integrity of data. Blockchain uses cryptographic techniques to ensure that once data is added, it's practically impossible to alter or delete it. This immutability is one of the key features that make blockchain uniquely secure and trustworthy. Blockchain operates on a decentralized structure where no single entity has control and all participants have equal access. The most significant difference between the two lies in their structure and the way they process and validate transactions. Traditional databases operate on a centralized structure where a single entity, say a company or organization, controls access and manages the data. This centralized authority can modify or delete data as needed. On the other hand, blockchain operates on a decentralized structure. No single entity has control, and all participants have equal access. It uses cryptographic techniques to ensure the integrity and immutability of data. Once data is added to the blockchain, it's virtually impossible to alter or delete it without the consensus of the majority of participants. When it comes to processing transactions, traditional databases do it sequentially, with each transaction depending on the previous one. In contrast, blockchain transactions are processed asynchronously, allowing multiple transactions to occur simultaneously. These transactions are then added to the blockchain in batches, known as blocks. The consensus mechanism is another stark point of difference. In traditional databases, consensus is achieved through the central authority, which verifies and validates transactions. In blockchain, consensus is reached through a distributed network of nodes. These nodes use consensus algorithms like proof of work or proof of stake to validate transactions. Understanding the differences between blockchain and traditional databases is essential for making informed decisions about your data management needs. So, we've explored the key differences between blockchain and traditional databases. We've seen how centralization contrasts with decentralization, the unique features of data integrity in blockchain, and how transaction processing varies between the two. Knowing these differences is crucial when choosing a data management system. Thanks for watching. Don't forget to like, share, and subscribe for more insights into blockchain technology and data management. Until next time, keep exploring, keep learning, and keep innovating. Goodbye.